Well, it's 10, so we'll go ahead and get started. Other people may or may not roll in. That's on them. I wanted to go over quickly what the format of the exam on Monday is. Yeah, just quick reminder. Thank you, Jalen, for reminding me of this. Everyone, make sure your masks are up over your nose, all that good stuff. Professors have been asked to encourage you all to do proper masking while in class. So. No. I'll use my outer mask. No, the schnoz, right? This doesn't actually protect anything. No, the chin strap, all that good stuff. So, but okay, so the exam, you have the whole class period. If you need about 10 minutes afterwards, that's fine. Actually, we can say even longer afterwards if we need to. All right, so there's 15. Ooh, this is like flimsy chalk ever. All right, 15 multiple choice, and those are 1 point each. So 15 points total, 5 questions for each of the 3 major topics, like the history of assessment, the ethics, and then this reliability and validity stuff.
Yeah.
What's that?
Can you repeat that?
Round reading question.
No. These are just 5 multiple choice from each topic.
History, ethics, and what?
What we're doing right now, reliability and validity. All right, then there are 10 short answers. And those are 4 points each. And most of those will be just short answer in the traditional sense, in terms of you're gonna write a few sentences about, a question I might ask you about history. Like there's like an ethical brief scenario. Things like looking at correlations and telling me, or like a validity or reliability. There we go. Reliability coefficient, which is basically the correlation coefficient, and telling me which one's the strongest. There is one calculation, so I'm going to make sure you have your calculator. And we're going to go over that formula next. That's actually the next thing we're covering. But it will be the Spearman-Brown formula. And you'll see it's really simple calculation. And this is just like a warm-up, basically to get you used to doing them on tests. And you will have the formula. The formula is provided, so you don't have to memorize the formula. You just have to literally plug a number into it. Okay. There will also be 3 extra credit points available as well. And remember, you also have your take home that you should finish if possible over the weekend. Again, if you need till Wednesday, because I gave it to you a little late, you can take that. But I highly, highly recommend doing the take home this weekend, because it will help you to study for the in-class. Whoa, okay, we have someone who's already done. Woo, okay.
So
I like to get it out.
What's that? Yeah, it's on Blackboard. Yep. Yeah. And if you have any trouble downloading it, at least one person did, just email me and I can email it to you.
how many questions are
There are 3 essay questions on the take home. So again, let me just show you all where that is again. This will be the easiest way to go. So if you go to Blackboard, maybe, there we go. Sometimes our network likes to just like take a break, I think.
How many points are the essay questions?
The essays are 15 points each. So between the essays and the in-class, you get to 100 points for the whole thing. All right, so take-home exams, if you click on that, and you can, it's up to you, whichever way you do things better. You can either type out the essay questions, or you can print it out and handwrite it and turn it in that way, whichever is easier for you. It's going to very slowly open here. I'm just gonna do it.
Yeah, let's turn that in on Blackboard.
No, I do want you to bring this in person, because what I do is I staple it together with your test and I just grade it all together. So you can either print out the typed one, or you can, yeah, or you can print it out blank and handwrite it and turn it in. So, yeah, I'll just keep this one with my files and staple it together. Oops, there goes mine.
Once they're moving around, so I could have it handwrite my.
Yeah, some of that stuff I'd actually recommend, yeah, probably handwriting your name and doing your signature after you print it out. That's fine. It basically, the thing at the top just tells you not to cheat. If you don't cheat, you're good. So yeah, so each of these is worth 15 points. And again, there's one for each topic. So how did psychologists become involved in assessment? There's a vignette where you see what Dr. Oops did wrong and talk about it. And then you talk about reliability and validity on the other one. So if you were to print it out and handwrite it, I would expect it to be like one side of the paper. So if you're going to type it, kind of use that as an indication of how long it would be. All right, questions about the format or anything about the test itself? I want to make sure we do this at the beginning so we don't run out of time at the end. Yeah.
So the essay portion, there's no essays on the other one.
Exactly. Yeah, and the reason I do that is because there'd be too much to have you do the essays in a 50-minute class, right? And I'd rather you take your time and actually like have some thought process and time to do the essays. So, and again, like they're to hopefully prep you a little bit for the in-class portion too. Yeah, so these short answers, they'll be like, you know, like a question written and then a little bit of space and a question written, and you're not expected to write any more than like that space in between. It's probably like 7 or 10 lines of return. And the only reason I make it so big is because I know my handwriting is big, so some people's handwriting is big, right? So if you have tiny handwriting, you might not even take up that whole space. Basically, for me, the biggest thing is to make sure you're answering every part of each question, whether it's on the essay or the short answers. And that's how you get points. You know, there is no right or wrong answer, especially for the essays. I mean, the like multiple choice and short answers will generally have them. But like for the essays, I don't really care if you even agree with me, as long as you back it up with some stuff from the book. That's fine, right? Any other questions? Good question. So let me grab here. So it's chapter 1, 2, and 5. And I think once upon a time, the validity and reliability one was 3 in an old version of your book, which is why it's a little out of sequence. So chapter 1, 2, and 5, and we're going to finish talking about 5 today. So it's nothing we haven't covered in class. I think I've replicated a lot of what's in the text in class. So y'all will be good. I know you will. Other questions about the exam itself or material that will be on the exam?
What is this lecture on chapter 5?
Yes, chapter 5. So we haven't finished chapter 5. We'll do that today.
Like where I saw it's like meeting with Dr. Myers,
Mhm.
that like, so when did we do?
So yep, you there's a link on my syllabus and on Blackboard to my Calendly, which is a website you go and you just sign up for a meeting that works for you. So just schedule it on whatever your own time works. So, and if for some reason none of my times work, just email me. I've done some meetings with folks at like 7 at night or things like that. So Yep, and I know that says it's technically due today, but remember, like, due dates are flexible throughout the semester. I just found, like, the first time I did this, I think it was after I got back from maternity leave. And if I didn't put a due date on it, just like no one did it till the end of the semester. And like the point is to like get you comfortable with talking to me and how to set up a meeting earlier in the semester. So that's the only reason I put a deadline on it. So yeah, good question. So yeah, if you haven't done your meeting with me yet, if you go to Blackboard and you go to professor information, there's a link right here that takes you to my page. And then you probably just need a 10-minute brief meeting. And then you pick the day that you're interested in, and it'll tell you what times I'm free. And you can just choose one that works for you. And if you forget, no big deal, we'll just reschedule, honestly. I've had a couple people forget, we've just rescheduled. Yesterday, I thought I could do one at one time, and it turns out I couldn't, so I just rescheduled with that person too, so. All right, any other logistical questions about the class? After this exam, we'll start doing more in-class assignments as well. So those will become more frequent. Okay, so let me go ahead and get our captions on. There we go. Okay, so we're talking about different types of reliability. We're almost done with reliability, I swear. And this next one is the one that this formula will be on the exam. So this is called the split half method. This is a way to look at reliability where you basically take a longer questionnaire and literally split the items in half and see how one half correlates to the other half. Or, you know, some people will do it randomly. Randomly assign the items. Some people will just literally take, let's say it's a 20-item questionnaire, the first 10 and the second 10. And that's fine too. Why might this be not as good? Why might this be problematic? Oh, it's just, why might this be problematic?
I mean, like, maybe the first half is like better than
Exactly, yeah. Maybe you're asking all the questions you need to ask in the first half, and then you get to the second half and they're irrelevant, right? Or maybe, you know, you have all the ones that actually are valid, which we'll start talking about next, in the first half, and the second half, not so much, right? Yeah, so exactly. The first half and the second half might not be equivalent. Or when we get to IQ tests, what we'll talk about is those items purposely get harder. Each item you do gets harder on each subtest. So like comparing the first and second half there might not make any sense, right? Because honestly, there are people who never get 2 items on the second half, right? Because that's not their strength. So some people do this to estimate the reliability. You can just correlate the 2 halves, but they'll underestimate the reliability simply because the way you calculate the correlation coefficient is partially dependent on sample size. So if you only have 10 items versus 20, your reliability might be lower just because you don't have so many items you're putting in. So that's why they use the Spearman-Brown formula, which again is the one formula you're going to have on your exam. And so the RHH is just the correlation between the 2 halves of the test. So what the Spearman-Brown R, or the RSB, tells you is if each of those had the same total number of items, basically. So if each half had the full 20 instead of just 10, this is what your reliability would be. So example here, and this is all I'm going to ask you to do on your exam with this. Again, this is just like a warm up to get used to doing math on these things. So RSB, okay, and let's say we know that our correlation coefficient between the 2 is 0.78, okay? So then we would just take that and plug it in. So this is the RHH. So 2 times the RHH, which is 0.78, divided by 1 plus the RHH, right? Is anyone good enough in their head to multiply that out? If not, I can grab my calculator. Then 1.56. Alright. So then we have 1.56 divided by 1.78, which I have actually the cheat sheet for myself here is 0.876 if we're going to go to 3 decimal points. So there you can see, again, if we're remembering the reliability coefficient goes between 0 and 1, and the closer to 1 you get, the better it is. We've just upped our reliability coefficient from a sort of okay one, like acceptable, to a 0.87 is actually considered very good. So again, it's a little controversial whether you should even do this or not, but pretty simple calculation there. So that's all you'll have to do on the test, is I'll give you the formula. I think it's this exact thing, I just copy paste the exam. And I will give you a different number from 0.78 and you just plug it in.
What's HH?
HH is half. So it's the correlation between the two halves.
Cancel itself out? Are we?
No, it doesn't cancel itself out because one is being multiplied and the other one's being added. So it's not like RHH over RHH, right? And you're actually manipulating that. So yeah, all you do is I'll give you the RHH, the correlation between the two halves. You multiply it by 2 for the top, you add it to 1 on the bottom, and then you use your calculator to divide, and you're good to go. Again, just a warm up to using math on the exam.
So the total number of questions would be your final answer, double. Times 2, is that right? I mean, I know it doesn't have anything, I don't want to confuse anybody, but if it's half, you get to 0.876, and that's just 1 1/2. And then you
No,
get-
okay, so basically, okay, so what you're doing, let me try to illustrate this. All right, so you're doing the split half. So let's say we have just, let's do 10 items, right? And so what you do is you sum up the total scores, right? You give a score for each item. They're very good numbers, right? Great numbers. And you sum it up for each half, and then you run a correlation between each half. And that's that RHH, is like the score on this correlated with the score on this is the RHH. And so the reason that then underestimates your reliability is because when you calculate the correlation coefficient, it accounts for the number of items. So this formula, Spearman and Brown worked out, allows you to approximate the reliability for the whole method. Yep.
And this probably most of the tools that we have to like write.
You would actually write it out. Yep, this would be one you write out.
And then I do like one more question, so like in the calculator, it came up like this, so do you just want us to do like the first 3?
Exactly, yeah, 2 or 3 digits is fine after the decimal point, whichever one you prefer, honestly. I've seen both in published journal articles, so. Other questions? Yeah, it'll be one of these. It'll be 4 points. So if you freak out and blank out, you're only gonna miss 4 points out of the 100-point exam. Okay, you'll be all right. I know you will. Alrighty. So internal consistency is honestly what we more typically look at when we look at reliability of a questionnaire. So this is, do all the items on a test measure the same thing? And it also allows us to look at whether all the items are actually contributing to our score, if there's some we can like throw out. Sometimes this is called inter-item consistency or inter-item reliability. I've typically seen it called internal consistency in published journals. So let's say we think we're creating a survey of liberal versus conservative attitudes. I love, Democratic politicians. Everyone deserves free healthcare. People just want a handout. The government does not pay for anything. Blue is my favorite color. I like ice cream, right? So here we probably have some reliability issues, right? We probably have some items that are not measuring what we want to be measuring. They're not going to be internally consistent. It kind of gets at validity too, right? Which is what we'll talk about next. And like maybe you could argue for the blue ones, since blue and red are affiliated with political party, even though I would argue not, right? And clearly the I like ice cream, probably not gonna be related. I mean, you certainly measure that, but it's not, political affiliation.
I did a survey on healing, and one of my first questions was, do you cry easily?
Nice, yeah. I think it changed with the MMPI 3, but for almost a century, the first item on the MMPI was, I enjoy reading mechanics magazines. Random, right? So do they go together in a single attitude? 1 and 2 are fairly liberal, 3 and 4 are fairly conservative. There are times we want to do that. We want to have some items in one direction, some items in the other. And then when we go to add up the scores, we do what's called reverse coding, where we'll switch one or the other. Or maybe we want to create subscales, right? So we'll have a scale within a scale that measures liberalism, a scale within a scale that measures conservatism. But as we just pointed out, items 5 and 6 probably not related, right? They probably don't contribute to the score that much. They're not consistent with the measure. And internal consistency is about how consistent the items within a measure are with the thing you're measuring, or with each other, honestly. Like the actual formula that's used to calculate internal consistency just correlates all the items with each other. Other ways you can calculate internal consistency, one is what's called the KR20. And so we'll talk about that one later. The one you see most commonly in publications is coefficient alpha. And that's the thing that I mentioned the other day. Uses the Greek letter alpha, which looks like a Jesus fish. So that's the one that pretty much any journal article that uses questionnaires reports in the method section. One other thing we might run into in psychology is there might be times where we're not having someone answer questions, we're not interviewing them. What we're doing is just observing their behaviors, right? So like one of my grad school professors told us about a study he was involved in where they observed the behaviors with kids with ADHD when they were on medication versus not. And so sort of noting down each time they got distracted or got up from their seat, ran around, that type of thing. He said it was kind of funny because the kids could tell the difference. They'd like come in the class and be like, it's a placebo day. So, sometimes placebos are the best because people know. So this is called inter-observer, or I've more clearly called it inter-rater reliability. So things that require subjective scoring, things like the Rorschach, have a little picture of Rorschach from The Watchmen here. We'll talk about that later. Sometimes if you're doing a study on like a diagnostic interview, you might have more than one person test and see if they agree. If you're observing behaviors, you have 2 observers, do they agree that the kid did the same behaviors? Basically, this is a check. If you send out just one person, they could have all manner of problems that would cause error, right? So by having more than one, you sort of try to account for that error. Can 2 people get the same answer? Going back to our example of the 40, right? If 2 people with a stopwatch time someone, do they get the same time? Do about low reliability. As I mentioned, the number of items. the way we calculate things, the more items you have means you're more likely to have good reliability. Now, if you construct a really bad test where all of the items are random, like I like ice cream and things like that, that doesn't mean that adding more items is going to make it better, right? But in general, if you're writing good faith items, that could happen. Factor and item analysis is a type of analysis we could do where you essentially allow the statistics to tell you whether you are measuring one thing or not. So it will tell you, yep, all these items are relating to each other, you are measuring one idea. Or it might say, let's think of our liberal and conservative one. Oh, it looks like you've got a whole host of items measuring liberalism, a whole host of items measuring conservatism. Those are relating to the other items that ask the same thing, but not really to each other, right? So in that case, you might have two subscales on there. And factor analysis lets you do that. Item analysis lets you know which ones you can take out, which ones are like not actually helping you. And then correction for attenuation is how you correct for measurement error. And there are crazy formulas for that. I'm not going to make you all learn. All right, so let's talk about validity for our last half of class here. So validity is answering the question, does this measure what it says it measures? So I'm saying I have a measure of body image. Is that what it's actually measuring, right? Or might it instead be measuring eating behavior, which is different, right? Or depression, which is different, right? So does a measure of anxiety, for example, measure anxiety or depression? We know they have some overlapping symptoms, right? We need to make sure if we're saying we're measuring anxiety, we're getting at anxiety. Is self-esteem measure, is it measuring self-esteem, so feeling good about yourself? Or is it measuring narcissism, which is thinking you're the best person in the world, right? And no one can tell you otherwise.
What is that definition again? How it measures what?
Oh, it's right up here in yellow. Does the test measure what it says it's measuring, basically? And school aptitude tests, right? All those wonderful SLOs and things, SOLs, yeah, SOLs you all have had to take. Are those actually measuring aptitude, or are they measuring how well you take a test? Or just one thing, like reading ability, right? These are questions that people ask when they're looking at validity. And honestly, before you introduce a measure, you need to test validity. And you need to show, like the first publication where you introduce, say, a new questionnaire, you have to show that you've looked at other things that might be related to, and it seems to actually be valid. So how is reliability related to validity, related to reliability? So remember, reliability is consistency. It's hitting that target in a cluster, right? But it doesn't necessarily tell you if you're hitting the center. That's validity. Validity is your meaning. Validity is you are getting at what you actually want to get at. Reliability is a necessary precondition of validity. That's a fancy way of saying if your measure is not reliable, it's not going to be valid. Partially, again, because of the statistics we use to calculate validity, if you have an unreliable measure, it's going to make it very difficult for you to find good validity just statistically when you go to plug the numbers in. But if we think about it just sort of philosophically, right, it makes sure that if you want to make sure you're measuring what you think you're measuring, you got to do it consistently, right? What's that?
I think that's terminology.
Yeah, kind of, yeah. So a test validity coefficient can never be higher than its reliability coefficient. Again, just based on the way it's calculated. So in order to be valid or to have meaning, especially the meaning we think it has, right? It has to be reliable. It has to be consistent. So, okay, what this slide really boils down to is a lot of words saying it's got to be reliable in order or to be valid, right? So knowing, yeah,
So like, consistency, like, what, because I know you were saying like all the dots.
exactly. Well, it's essentially, so let's think of our questionnaire example, right? So consistency would be that all the items are measuring the same thing.
Oh,
Yeah, and so in order for us to be sure that the questionnaire is measuring what we think it is, all the items have to measure what we think it's measuring, essentially. It's basically kind of saying in its own way that each item has to be valid in some way. Yeah, that was really good. That helped me rephrase it. So thank you for that question. So how do you demonstrate validity? It's really similar to establishing evidence in a court case. It's not something you can do one calculation and be like, yep, we're good, it's valid. It's like you have to sort of build it up. You've got to build evidence to demonstrate your assertion that this is a valid measure of, whatever construct we want to look at. So you are going to be showing this over and over. And those of you who took personality with me, we talked a lot about how this is a lot of what happens in psych science. Is like we spend time trying to show a measure is valid. And in so doing, we're also showing that basically the idea it's measuring is valid in and of itself. Yeah, kind of. So what questions would a validity study assess? Yes, you could have a whole published article that just looks at validity of a scale, particularly if you're using the scale in like a new population, for example. So does the test adequately measure the domain being tested, right? We could have a good, consistent measure of depression that never asks about how people are feeling, right? Because there are a lot of other symptoms of depression that are sort of physiological. That would be an example of not measuring the whole domain being tested, right? We want to make sure we get at everything in whatever that thing is we think that we're creating a measure of. Does it correlate with a standard against which it's compared? So typically we'll look at existing measures that measure either the same construct or something that should be related, right? So let's say no one had ever invented a measure of depression ever, but we know that people who are depressed are sometimes also anxious, right? Our new measure of depression should be correlated with a measure of anxiety. So sometimes it's a pre-existing measure of the same thing. Like if we created a new depression measure, we'd probably correlate it with the CES depression scale, because that's been out there and used for a while. And sometimes it's similar concepts. If it does correlate with what we think it is it current or future? So one of the things we look at is you fill out a questionnaire about depression now, and you fill out your new question of questionnaire now, right? That is current. But eventually, particularly in applied psychological settings, we want measures to be able to help us predict things, right? So if I give someone a measure of depression now, can that predict behaviors like, whether they'll engage with therapy? Are they more likely to self-harm? Things along those lines. So as we amass evidence about a questionnaire, we will do all of these types of things. And again, the biggest question in validity is always, is it actually measuring our targeted construct, what we think it should measure? Depression, intelligence, what have you. So there is a particular type of correlation coefficient called a validity coefficient. They can be pretty high, like in 0.60. But if they're in 0.3 to 0.4, that's considered good. If you get too high, if your correlation between your new measure and existing measure is like 0.9, that basically means your new measure wouldn't add anything to the literature. Because it's basically measuring the exact same thing as the one that already exists, right? So like, why create this new one when there's already one that does it really well, right? So the 0.3 to the 0.4 range, that's good. 0.6, outstanding. And same as other things that we'll talk about in this class, the P is less than 0.05 means that it is unlikely to occur by chance more than 5 times out of 100. So that's actually like not a ton of certainty, right? But that is the criteria that someone established a long time ago, that P is less than 0.05 or 95% out of 100 accurate. Okay, it's an A, right? But it is something to kind of think like, oh, why is that what we go with? All right, there are a bunch of types of validity. As with reliability, each of these is going to have its own slide, so don't worry about scribbling down this list. And we'll start with face validity. So in like the statistical calculating sense, it's not validity as we traditionally think of validity, because it's not really evidence of meaning or of it relating to the concept or construct we think we're measuring. It's just, if you look at a test, does it look like it's measuring what you think it's measuring? So if I were to read the items on a depression scale, could I say, yeah, this seems like it's measuring depression? So why bother? Well, it gives the appearance of validity or meaning to the test taker, and as a result, it can improve their motivation to fill it out accurately. So sometimes what I do, and I'm not going to do this to you all on a Friday morning, but is to like make people do calculations in their heads in this class, you know, ask, if I were to do that, what would I be measuring? Can you do calculations in your head, right? So it's like, is it measuring what we think it's measuring? Another example would be a thermometer, right? It measures temperature, but does it have face validity? Not really, right? Unless you have context, you don't really know what the number 79 means for how hot or cool it is. If you want to understand that, try to look at the weather in Celsius if you're not familiar, right? The number feels almost meaningless because you don't understand. Like I remember I arrived here from the UK one time and I was on Virgin, one of the British airlines, but they gave us the temperature in Celsius and everyone on the plane was like, whoa. And I was like, oh, I guess that's hot. I don't know, right? Yeah, Troy, did you have something?
Yeah, it has to be qualitative, or else you wouldn't be able to match the frequency of it, so to speak. When you're looking at the test, does it look like it's
Exactly.
about this?
Yeah, so that's exactly it. So this one,
Frequency, so.
yeah, this is just qualitative. If I
And then
read it,
makes the test more factual.
does it make sense? Yeah. So some people argue, who cares about this for psychological, and there are psychological tests that don't care about face validity. So one of the constructors of the MPI, one of the big personality questionnaires we'll talk about later, liked to brag that he never read all the items because he didn't care what they actually said. He just cared that when he ran the stats, they gave him the information he wanted. Other times you want people to look at it and go, I know what this is measuring. I can answer this honestly, right? So then we start to get at content-related validity. So essentially, is it adequately getting at the whole idea of what it's trying to measure? So, like when you all take this exam on Monday, did I adequately pick questions from chapter 1, 2, and 5, right? Or were all the questions from chapter 5? I'm not going to do that to you. But that would be an example of poor content-related validity. If I told you, study question, chapters 1, 2, and 5, and then I only asked you about chapter 5, right? Poor content validity. And so this has some logical pieces to it, but you can start to look at statistics with this as well. And that turns into criterion-related validity. So how well does a test score relate to a particular standard, or you'll hear it called a criterion? We like to use lots of different words to mean the same thing in psychology. It gets a little annoying sometimes, to be honest. So what's a criterion? So a criterion is essentially what you are going to compare your scores to. So let's say this is Suicide Awareness Week, right? So let's say we had a measure of suicide risk. What would be a criterion we could compare that to?
Last year, you know, last
Right, it could be, whether or not the person attempts suicide, right? When we're getting at criterion-related validity, that's actually what we're trying to do, is can this actually predict someone's behavior, for example? Right, or let's say we're giving someone a driver's skill test, like, a road test before you get your license. What are we trying to predict with that? Yeah, can you drive? Can we let you out on the road without someone else in the passenger seat, right? Or are you just gonna go and be sheriff from Clueless? And, right, are you gonna be sheriff from Clueless and like drive through everyone's mirrors, right? When you go down the road, right? Yeah, so that's criterion related validity. Essentially, like, is this actually able to predict what we want it to? Something like a medical practitioner licensing test, right? Can you go out and do your job without unnecessarily harming people because you actually know what you're doing, right? Rather than just sort of guessing. And there are two different kinds. The one we've been talking about is predictive. So predictive is when the purpose of the test is to predict how you will do in the future. So like some people do premarital counseling, and it might include like a compatibility test. So ideally, that compatibility test should predict how many years you'd be married, for example, or how happy you are in your marriage, depending. LSATs, right? In theory, should predict how well you're going to actually do in law school. Kind of what we talked about before with the GRE, though, you're limiting your window, right? Because you're only letting in the people with the highest LSAT score. So it makes it more difficult to kind of determine if that's true or not. And there's a lot of evidence mounting. I don't know about the LSAT in particular, but about the GRE, for example, that shows that it's actually not a good predictor at all for people who are minoritized. So people of color, people who are first generation college, things along those lines. Might not test well, but would do great if they went to grad school. So again, a lot of people made it test optional this year, didn't require the GRE. It'll be really interesting to see, hopefully, if that diversifies the workforce. Concurrent evidence is where you simultaneously administer your new test and a measure of criterion, right? So maybe you're going to give a learning disabilities test and you're going to look at their academic performance as a criterion simultaneously. So what is their GPA or how they're doing their classes for this semester? So when you all do your group project, this will be a big part of what you do, where I'm going to help you all find an existing measure that looks at something similar to what you are proposing with your new measure, and you will compare the two scores, and you'll give them simultaneously. So concurrent is, you're going to look at everything right now. Predictive is, can this tell how someone will do in the future? Again, like the driving test. Can that say, you pass this, in general, we think you're not going to commit vehicular homicide the minute you drive off this lot, right? And so you hear this term construct a lot. And it's just a word that means concept, an idea, something that's built or constructed by mental synthesis. It is a really fancy word for saying, this is something I can't directly observe. It's an idea that's sort of intangible, so I'm going to call it a construct. So things like intelligence, right? I can't see intelligence, but I can come up with ways to define and measure it. So that's a construct.
Love.
Love is a really good one. Yeah, we can't see that. There are tests of like love or compatibility between people. Introversion, shyness, right? I can't just look at someone and determine how shy they are, but we can give them a measure that helps us figure that out. Depression is the same way. There are people who are extremely depressed who just put on a good face every day and go through life, and even their closest friends have no idea, right? But a measure of depression will help us figure that. And physical health. Again, there can be people who look perfectly healthy, and they go to the doctor, do an assessment, and they find you have a tumor, right? Or, oh, you have high blood pressure, and go on those lines. So, construct validity is not something you can do with one little stat like we can with reliability, unfortunately. It basically overarches it like an umbrella term over all these other different types of validity we just talked about. And so it's established through a series of studies. So pretty much anytime someone is using the measure, they're doing construct validity, even if that's not what they explicitly were going to do in their study. So it's assembling points of evidence about what a test means. It's an ongoing process where the construct is gradually defined and clarified. And sometimes through the process of using this test in multiple studies, you start to realize, even though it initially looked good, maybe now it's not working as well. You know, maybe something has changed in the way people define things or interpret things. So for example, I think about the original MMPI to the MMPI-2, they actually had to take out some questions because the MMPI is sometimes used for hiring purposes. And there were questions on there that were illegal to ask, right? But in the 40s, when it was constructed, no one even thought of it could be illegal to ask someone a question, right, to hire them. So you might need to revise it based on revised knowledge, insight, just differences in the culture as well. So convergent evidence is where it correlates well with other things that should measure the same construct. So all these measures that are on here are measures of intelligence for kiddos. And they all tend to be very highly correlated. That's what we want, right? If these measures are all saying they're measuring the same thing, they should be highly correlated, right? If they're not, one of them isn't measuring intelligence. Divergent evidence is also something you're sometimes asked to look at, or you sometimes want to look at as a person constructing a test. So this answers the question, why create a new test if something else already exists? What's unique about it? Yeah. Basically, does it relate to existing tests that measure the same thing? So yeah, divergent allows you to say, this is different than stuff that's out there already, right? And it's done right. So I'll give you an example. One of my published studies is something I co-authored where we created a new measure, and this is the paper I have an example for y'all on the Blackboard. We created a new measure of things people do to feel sexy. And these are like everyday things. Some of them are like grooming things or choosing certain clothes. And they were like, but these measures already exist. So on a revision of the paper, we actually went and correlated it with those existing measures. And I'm not joking, one of them, the items were like, I would be in a Girls Gone Wild video. And we were like, yeah, this is really different than the stats showed it, right? But like, this is stuff people do every day versus like might do once in a lifetime.
Right.
So, yeah, sometimes you're asked to tell them as well. They're both useful. It tells you how much it overlaps and then what is unique about it that's going to add to the field. Criterion reference tests are also something that are sometimes used. These contain items that are designed to measure certain instructional goals. And your criterion might be percentage of correct answers. So for example, in our department, we do this, or we have you all do a test in Psych 495 that just measures general psychological knowledge. It doesn't go into your grade. We just use it as how well are we teaching y'all what we should be teaching y'all. SOLs are the same thing. So validity measures compare test scores to score on other measures believed to be related. All right, one last slide, just to be thinking about it. Kind of tying us back to chapter 2. Testing is big business. There are companies that get very rich off selling these kits. Very, very pricey. And so we always kind of need to be aware in the back of our head, who created this, who's
Yeah,
profiting
Good
from
check
it,
on that.
right? Yeah, I mean, there are some personality questionnaires where the author gets all the money from it. So the MMPI, the authors don't get the money. They get the money from the books about it. But when someone gives a test, they don't get that money. So
Yeah.
those things we gotta kind of wait. Alrighty, excellent job, y'all. And please, over the weekend, email me with any questions you have about the test. But I